Hey guys, how you going? MiracleMAX here. Welcome to another repair video. This time we're having a look at a toaster that keeps on blowing the circuit breaker. Wife plugged in the toaster the other day and it blew the circuit breaker. She thought, well, perhaps it's because I've got the microwave oven on as well and it's drawing too much current. She's a smart lady. So what she did was she turned off the microwave oven and she turned on the toaster. Oof, off went the circuit breaker again. So she had to race outside and reset it. Then she took it out of the power board that it was attached to and plugged it directly into the wall, put it on, poof, it blew the circuit breaker yet again. So why is it doing this? Let's have a look, let's pull it apart and check it out and see if we can make this complex thing into a simple answer. So how does this toaster work? Well, it's a fairly basic setup. It has your input wires here and here, straight from the power point. It goes through a resisted wire, which are these two internal ones, and that creates the heat or the red element that actually cooks your toast. No, which cooks your bread and converts it into toast. As we push down on this lever here, you can see it touches these two contacts here and here, which turn on the toaster. And here is a little locking assembly that relies on a solenoid to pull it in, which actually holds the toaster in place until the toast is done, and then it releases it. It's a fairly basic setup. So let's have a look at it in a little more detail. If we have a close look at those two contact points, you notice that they're quite pitted. Now you might think, oh, this could be half the problem, but think about it. If it has a higher resistance, it would have less current. Therefore, there wouldn't be enough current to trip the circuit. So therefore, this can't be the problem. Just to prove the point that these aren't the problem, I'll show you the resistance readings. So the measurement of our resisted wire that goes all through the toaster to create the heat to cook our bread into toast is measured with my multimeter, and it comes up as 30.3 ohms. Now let's compare that to when we close the switch and see how that measures. As you can see, I've got it connected through my active and my neutral straight out of the plug, and when we push down on our switch, let's have a look and see what the multimeter reads. There we go. We've got 31.7, so really there's hardly any extra resistance across those switch points. I will clean them up, but that's not the reason that we're having a problem here. Let's have a look further. So how do I know if the current being drawn by the toaster is acceptable? Is it within specifications? Is it too high? Why is it tripping the circuit? All these questions need to be answered. So how do we find out? I have actually made up a piece of equipment, very basic piece of equipment, that will help me find the answer. I've got a power point that I've just put on a normal lead. So as you can see, it just goes straight into the back of it, which is fine. And also I've got a current clamp, which will help me to come up with the correct reading of it. As you can see, I've actually spliced into one of the wires there. I've only got one wire exposed, as you can see through here. The reason being is if I put the clamp over both of them there, it will read 0 because we have current going one way. To complete the circuit, it comes back the other way. Therefore, it would read 0 if I clamp there. Therefore, I must expose one wire, complete with the shielding attached, of course, and then I can put my current clamp over there and I can read what the toaster is doing. How do we know what's acceptable? Let's have a look at the specs. So I flipped the toaster over and you can see underneath the specs there, it's a 240 volt system, of course, 50 Hertz, which is what we have here in Australia. But notice the wattage, it's can't quite see, I think it's 1650 to 1800. So how does that help us? Well, Mr. Watt will be able to help us. What do I mean? Watt's law. That will help us to work out the current that this circuit should operate at. So James Watt is the guy that is going to help us to figure out what's wrong with our toaster, believe it or not. He was a Scottish inventor born in 1736. He became a civil engineer and an inventor, and although he didn't actually invent the first steam engine, he dramatically improved it, so he made it more successful. And he's the guy that actually came up with the term horsepower. So if you have a look at the formula there, we've got power is equal to voltage times current, and power is actually measured in wattage. So let's have a look at the whiteboard and see if we can figure out what sort of current our toaster should be using by using Watt's law. Okay, if we start at the bottom end of the scale for wattage, it was 1650, wasn't it? 1650 watts. And that was equal to 240 volts, which is what we have here in Australia. And we need to find out what the current is. So it's quite easy to do. All we have to do is do 1650 divided by 240, which is equal to 6.875 amps. Okay, so that's what we should expect the bottom end of the scale. So the top end of the scale is 1800, and once again with the same formula, we know that it's 240, and the top end of the scale will equal 7.5 amps. So what's our toaster actually doing? That's what we need to know. I'm just about to put the toaster on and see what sort of current we're drawing. I'm being extremely safe. The plastic knob has been put back on, so there's no chance of shock, and also the release button down here I can push externally, so there's no chance of getting a shock on that. I might just turn the toaster down so it doesn't go on for very long, just to find out if it's going to operate correctly. So let's switch it on and see what happens. It's holding in, so that's a good sign. It's reading, went up to 8 there, but it's back to 7.7, 7.5, and it's actually going to drop. The reason being is because as it heats up, it creates higher resistance. We know that if there's a higher resistance, there's going to be less current. Therefore, that should slowly come down, as we can see. And hopefully it should pop out when it's done its time. So far it hasn't tripped the circuit in any way, which is a good sign. You can clearly see the current draw coming down as it heats up. It's popped out. So why is it working? Let's sit down and discuss it. Why is this toaster now working whereas it didn't before? What was the problem? Well, one of the major things obviously when you're cooking bread and making it into toast is all the crumbs that drop off. What happens to those crumbs? Well, they build up carbon, don't they? And carbon is actually conductive. So what happens is when time passes and there's a lot of carbon build up, we can end up with connections between these various points, which are our resisted wire. If they contact, they will therefore make a shorter resistance. They will make a component short. And what does that do to our resistance? Well, it lowers our resistance. What does that do to our current? If we have lower resistance, we have higher current. So much so that in the end it gets our 10 amp circuit breaker. So even before I pulled this down, I decided to give it a really good clean out, and as I took the top off, there was quite a bit of carbon, quite a bit of crust, etc. in there, and I've given them a really good clean out. And now that's why we've got our current within the specifications that they should be. So I'll put it back together and make sure it works on a regular basis before I call it a fix. So I've thoroughly tested this toaster up and down, up and down, up and down, heaps of times, happy with the results. So obviously there must have been a carbon build-up track between the resisted wires, therefore shortening the resistance, making the current too high, tripping the circuit breaker. I hope you've enjoyed this video, guys. It's short and sweet, fairly basic, but it gives you an idea that all appliances, no matter what they are, as simple as a toaster, even needs maintenance. So clean them out, make sure you get rid of all those crumbs, then you won't have this sort of problem occur. Thank you for watching this video. If you enjoyed it, give it a thumbs up. If you haven't already, please subscribe and feel free to comment down below. So until next time, this is MiracleMAX. Catch you later.
Bye.